Hi, I'm Nathan, and in this video I'm going to be taking you through how to make field functions in STAR-CCM. In this video I'm going to be making two different field functions, the first being a scalar field function, which is much simpler, and then the second, which is going to be a vector field function. So first here we're doing the velocity magnitude, which is quite a simple function. As you can see here, we've named it, created it, and then we're defining here our field function. So there's a few vector functions here that you can use. I'm just using magnitude, which is one of the simplest ones here. And then we're looking for velocity, and it comes up as seen here. And here we have our first field function. This is generated, so we're going to want to visualize it by creating a scalar scene. And then in the scalar scene we need to select which scalar field we'd like to see, this being the velocity magnitude field that we've just created. So this video is following on from my previous video where I showed you how to do lid driven cavity flow. This is slightly separate as this is specifically for field functions, but as you can see here, before we had prescribed the top velocity to 1, and as you can see the top's 1 and the rest is 0. With 0 no-slip boundaries. So the second field function we're going to create is a velocity lid distribution. Lid-driven cavity flow is a classic fluid dynamics problem, with one of the struggles of modelling this being the singularities in the top corners. So one way of dealing with this is prescribing a lid distribution, not 1 everywhere, but 1 in the centre, and then towards the outside it will tend towards 0. As seen in this paper here, this is a lid distribution which tackles this problem, and I'm going to be implementing this as our field function. This is a much more confusing function, so you have to be careful when generating this. So this is power, this is that squared, that big bracket squared, 1 minus, and then in the paper he didn't minus 0.5, but I'm going to minus 0.5 from the position because my box is not centered around 0, 0. In his paper, his box is centered around 0, 0. So here I'd like to draw you to this position 0. So this is the X position, as in STAR-CCM it is 0, there is 0 indexing. So as we see here, 0 is X, 1 is Y, 2 is Z. And then this is times by the same for the Y direction. There we go. Now, first thing to visualize this is we'd actually like the lid to take this lid distribution. So in the velocity prescription, we're going to change this from where it was just 1, 0, 0 to now this field function. Velocity lid distribution. So we're clearing the old solution, start again with this new lid distribution. Now we just want to plot the velocity magnitude, and as you can see here on the top, this is this lid distribution we're after, and it stops the singularities in the corners. You can see the same for the velocity vectors here. So I hope this has been helpful. Thank you for watching the video.